Okay. Hello, this is Brian Purdy with Florida Aviation Network. Today we are at Verticon 2026 in Atlanta, Georgia, visiting with Rex Alexander of 5 Alpha.
Yep, that's right.
He's given a couple presentations here this week, and we just sat through one, and now we're going to spend some time, and he's going to tell us about some of the things that are coming down the pike, especially with vertical aviation. Good afternoon, Rex. How are you doing?
I'm doing great. Thank you, sir. As far as here at Verticon, what we talked about on Monday, we actually had a forum. So VAI has a group called the Infrastructure Advisory Council, or AAC, for vertical flight. Our advisory council meets every month. Anybody that's a VAI member can be a part of that council. But we put on a forum on Monday, which is 6 hours in length plus an hour for lunch. We covered 4 specific topics. We looked at the infrastructure from a whole when it comes to the data that we capture. So the data that's in the airport master record for either an airport, heliport, seaplane base is in what's called the airport master record that the FAA keeps. So one of the things we look at is the accuracy, integrity, and the recency of that information, because we're using that information to base a lot of decisions on. Currently, there are a lot of errors in that information because the FAA doesn't go through for private heliports and check that. They don't have the staffing. The challenge is there are 5,800 heliports in the U.S. and almost 99% of them are private. So at any given day, you never know what's current. The challenge then being is everyone that actually provides information bases it on that database. So when you look at if you go into your GPS on your aircraft and you dial in a particular location, it's that database they're pulling from. Well, if that information on that GPS happens to be wrong, which we found in one case in Tennessee, the heliport's 55 miles in the wrong direction. Guess what? Your GPS is going to lead you in totally the wrong direction. We looked at working with the FAA, specifically identifying those particular items. We had people from the FAA and industry having those discussions. We had people from the FAA's Technical Center there in Atlantic City. We had people from FAA Standards there. While we didn't get a representative from FAA Airports, we did get a gentleman who works in that space as a representative on contract. So we did get that covered, thank goodness. But walking down that, say, okay, what's the data we want to capture? What data don't we capture? What are the fields that we want to increase our accuracy level on? One of the challenges we've always run into with heliports compared to airports is if you look in the airport master record and it says runway, it's going to have a number. It's going to say, let's say 1836. Well, it's pretty obvious that that means the approach departure path happens to be 1836. You look at the exact same column, it just lists an H for a heliport. We have no idea what the approach departure paths for a heliport in the United States are because we don't capture them. Even though we have to file the 7480 to propose the heliport, we have to put that in there. The airport master record and the 5010 form don't capture it. So that's a real challenge when we get into telling pilots, well, what's the approach departure path? No one knows.
I guess you can come in from any direction.
Well, and that is key, but what we're looking for is being able to provide them with the approach that the FAA has looked at and evaluated for obstructions.
Okay. Yeah.
The pilot is expected to do whatever's the safest. If that means coming in from a different direction due to winds, he has that authority under Part 91. He is the ultimate authority. As long as he does it and can explain it, not a problem. But that information for the approach departure path for 60 years is non-existent. So we're trying to fix that and several other things. The other topic was the new standards. So currently we have standards for heliports and we have standards or partial standards for vertiports. So for heliports, we have what's called the FAA Advisory Circular 150-5390-2 Delta. Now, that advisory circular has been in print since 1959. There's been 11 revisions. 2 Deltas, the most current, came out in January 2023. Heliport design criteria, recommendations from the FAA. Several different changes over the years. In the last 5 years, we came out with Engineering Brief 105 and then Engineering Brief 105 Alpha for vertiport standards. So it's not an AC, but it's an engineering brief. What they're currently involved in with the FAA airports and every other division in the FAA is they're taking those two standards and they're combining them into one. In 105 Alpha, they came out and specifically said that all vertiports are a subclass of heliport, which is great because all the municipalities out there don't have any ordinances on the books for the most part. There's some that do for vertiports. They do for heliports. So by calling a vertiport a heliport, we have saved a tremendous amount of challenges for the people trying to do this because the ordinance doesn't have to be written. Okay. We just need to make sure that we address it properly. But right now, we are in the process of that rewrite. In talking yesterday, the FAA has suggested they don't put anything in a positive timeline whatsoever because everything slips because of politics. Hopeful that we'll see the draft of that new AC. It's not going to be the heliport or vertiport AC. It'll probably be Vertical Aircraft Infrastructure Advisory Circular, which will combine those two. The other piece that's interesting is these new aircraft that are coming onto the market for eVTOL that are not powered lift fall into this extreme short field takeoff and landing category. So those still need a little bit more, but they're looking at putting that standard into these standards. Yet to see what that looks like. They're going to publish this out to the public, and it'll go out for public comment. Vertical Aviation International, along with the Vertical Flight Society, General Aircraft Manufacturers Association, NBAA, who was the other ones we worked with? EAA and AOP. We all work together, read through all those new standards, get together, say, oh, what do we like, what do we don't like, come up with some new language. We put that together and then provide public comment back to the FAA. FAA has been exceptionally good about responding to things that we say, hey, we really like it to read this way, not that way. That'll probably be, I'm hopeful we'll get a 60-day window. We might get lucky and get a 90-day window to provide public comment. Once they do that, they'll pull that all together, adjudicate that, run it through legal and all the other divisions, and we expect to see a new standard probably on the market, as long as we don't see any political slip, probably by the summer of 2027, my guess. So I don't see any huge changes. But there are a couple things in there that came out in the EB 105. It'll be interesting to see how they implement, one of which is this downwash, outwash caution area. What they said with the EB, which is primarily for vertical aft, but it also applies to helicopters, is if you have a velocity of greater than 34.5 miles an hour, you should then have a downwash caution area, not a zone, but an area. So that means I have to figure out who's going to produce that. The two primary factors that you calculate that number for is rotor diameter and weight. As rotor diameter decreases, downwash increases. As weight increases, downwash increases. It's all based on that area that's creating lift. So while smaller aircraft do create that, it's usually not an issue, but can be. Bigger aircraft, and they had this problem in the UK. They actually had a fatality, and then here recently they had one in Japan with an Air Force UH-60. The one in the UK was an S-92. So I'll be interested to see how we address that. We're looking for tools that we in the industry can use to help, apply that, because okay, you gave me a limitation, but I have no way of applying that limitation. So it's interesting. So the AC, the standards is the second subject we covered. The third subject we covered was weather cameras. So in Alaska, we had a lot of weather cameras going into very remote places. Now, that's been an FAA program. They have really went out of the way to put weather cameras in these really hard to reach places that are remote as all get out because they were having accidents all over the place. We're now seeing those weather cameras migrate to the lower 48 and CONUS. The first major adopter was Colorado, putting them up in the mountain passes. Then we saw Hawaii put in several for the tour operators in those mountain passes. So it gives the pilot the ability to see the weather visually at these locations. Some of the newer ones actually have 360-degree live camera feeds.
So it's like snowstorms or fog or anything.
Oh yeah, whatever you look at and you see, what you'll do is you'll go out and see here, okay, the camera's here. That mountain peak over there I can see is 5 miles away. All right, I'll mark that and I'll know that. So if I can see the mountain peak, I know I got 5 miles. Okay, this peak happens to be 3,000 feet high. Okay, I know I have 3,000 foot of visibility. It's the poor man's AWAS, but it's really, really good, and we see pilots really adopting the information. So the FAA has done a fantastic job in that. The gentleman we had speak for the FAA has been in charge of that for a while. It's Cole Pope, phenomenal guy, has been doing great work. A lot more to come for that. Now we're starting to see non-federal money being thrown at this in the lower 48, and we're starting to see people put in cameras in conjunction with AWASs, because an AWAS is a great tool, but it's only giving you very finite level of information. Better than a windsock, but still, a weather camera will give you a whole new piece of the picture that we're looking for. Big safety factor. And then the fourth thing we talked about was this downwash, outwash. So there's a lot of research going in that space. The FAA Technical Center has been working on it. I've been working on it myself with a couple of different universities. The UK Civil Aviation Authority, there's a gentleman over there at CAA, Mike Price, has been doing some great work along with a gentleman by the name of Richard Brown, who works for his company called Sophrodyne. They've done a lot of the white papers and the research. There's been a lot of fluid dynamics modeling done by different companies here in the U.S. Continuing Dynamics is one. Wind tunnel testing, RWDI out of Canada has been doing that. I get to work with both of those groups. A lot of that's been going through kind of the Vertical Flight Society because they're the more technical side. If it's an operational side, it's primarily in the VAI side. When we get into the technical world, it's usually over in the Vertical Flight Society side.
Now, is that also when they say wake turbulence for helicopters, that they're talking about the downwash?
Good question, because when we look at it, there was a big push in the past 5 years, specifically by the group NAFI, the National Association of Flight Instructors. One of the guys I've talked to, a good friend, Ned Parks, was really spearheading that. Wake turbulence and downwash are the same thing, just under different phases of flight. So as I'm flying through the air at airspeeds above effective translational lift, I'm creating wake turbulence. It doesn't go away. But that's the downwash that I'm creating. That's because of the forward flight above ETL is behind me. That's what Ned and his group at NAFI have been talking about. Is like, being cognizant of not flying through that as a small airplane. Now, once the aircraft drops below ETL, I slow down. Now that column of air is going down. That's the downwash. Once it impacts a structure, be it the ground or something else, now that gets redirected 90 degrees. That's the outwash. That's what's causing the issues, the downwash and outwash in proximity to the landing area. So we're trying to get our arms wrapped around, well, what's that mean to me as an infrastructure developer? How do I protect against that? We have the National EMS Pilots Association. When I was working with them, we came up with a sign just as a warning, and it's ANSI, meets ANSI criteria. ANSI and OSHA define things as caution, warning, or danger. So based on what we knew, it met warning criteria. So it's an orange sign with black, and it basically says stay 200 feet, warning, downwash, and high noise. We put those around just as an alert to the people. Now, the other thing is education on the people. That's one of the other big pieces. But the downwash and outwash piece is one that's really hot topic right now. We look at the eVTOL world and the helicopter world, both have downwash and outwash. Which one's going to have more or less? Not 100% sure, but right now current testing is showing the eVTOLs could have a little bit more based on the configuration.
Could that be based on the number of rotors that they have?
It's the size of the rotors, number of rotors. It's a cumulative effect. One of the things you look at that helicopters have a minimal amount of, look at the V-22 Osprey. So you have two rotors producing two columns of air. The outboard side will flow outwards. The inboard side will actually collide, and it'll create what's called a fountain flow effect. So that fountain comes back up, impacts the base of the helicopter, and the helicopter is going to do one of these. The average V-22 pilot doesn't like to hover a lot because it gets beat on pretty good. The other side to that is it also creates what they call lateral darting effects. So that's what that is. eVTOLs, multiple rotors. Now you're going to have multiple streams of air. In the V-22 world, they always say don't stand in front of the aircraft because the wind velocity there is greater than it is at 45 degrees, because when those two flows collide, it actually accelerates the air. So there's this flow forward and a flow aft. So you don't want to be there. Now, what's an eVTOL look like? They're doing work on that right now.
I had a quick question. When you referenced the extremely short takeoff,
Yes.
are they looking at potentially just making a bigger square or making it a rectangle with the direction?
Good question. That came up yesterday. We talked about it a little bit. I asked the question to the FAA. I said, if I'm flying these extreme short field takeoff and landing aircraft, can I land on a heliport? I know some of those answers. Some of them yet to be defined. A lot of it goes into the performance capability of the aircraft. So the people having the aircraft have to prove that the aircraft is capable of not only landing and taking off, but dealing with a malfunction. So in a helicopter, if I have a malfunction, I have this thing called auto rotation. Yeah. That was designed in the heliport design way back in the 70s and 80s, and that goes into the size of the FADO and the safety area. So the touchdown liftoff area is your physical location, the landing and takeoff. The final approach and takeoff area is your maneuver area. It's not a physical structure. Safety area is what we call the fudge factor. Something bad goes wrong, we want to give the pilot enough room that he's not going to hit something. Now, what's that look like for eVTOL? There's a little difference in the geometry that when we look at the TLOF, it's based on the overall length of the aircraft multiplied by 0.83. That's based on the main rotor. Whereas an eVTOL, they're looking at overall length times 1. So it's a little bit bigger TLOF. The FADO, final approach and takeoff area, is based on 1.5 times the overall length of the helicopter. It's actually 2 times the overall length or overall width, whichever is greater, the eVTOL, and then 2.5 times for the safety area. So the geometry is a little bit bigger for the eVTOL. There's several different factors that go into that.
And that's going from all of the rotors, not just the fuselage that people are in.
Right.
Okay.
So.
Wow. Okay. Well, I think we've pretty much talked about everything you wanted.
Well, there was one other thing I was going to do. On the standards thing, there was one thing that just popped in my head. So we talk about FAA standards. There's another standard out there that we point to and we work with is the National Fire Protection Association writes standards for NFPA 418 heliports and vertiports. Now, that's not a regulation unless the municipality or state adopt them as code. Now it becomes regulatory. NFPA 418 points to advisory circular for the heliports for the FAA. FAA advisory circular points to NFPA 418. So it's a cross-pollination of reference. NFPA can be regulatory if referenced by the municipality or the state. We are in the process of the next revision cycle for NFPA 418. There is criteria in there for vertiports already. We're going to polish that up a little bit. We will be having a meeting in April for our first draft. That will be published out to the public and probably will be open for public input starting in October. That will probably go through January. And then once we get that done, we'll come up with the second, which will go through what the NFPA calls I can't remember what the acronym means, NITNAM, which is they go through and check it and make sure it's good. As long as the NFPA Council and Board are happy with it, then it'll be published probably in 2007 or 2027.
In that situation, I think it would be best, okay, where are you going to put your chargers and electric lines? Make sure you find that out before you pour the concrete.
Good question, and it's one of those things that we normally probably won't see chargers at the landing area. It's probably going to be off to a parking area. Now, if it's a single landing area, no parking, yeah, that might work. But it doesn't fit the business model of the eVTOL community that wants high throughput. High throughput demands parking. Well, that's where you'd put your charger. Now, that said, the FAA has partnered with, and their name just changed. It was used to be called the National Renewable Energy Laboratories. They're out of Colorado. They're a government agency. They wrote the documentation that's in NFPA, or not NFPA, EB 105 Alpha. They've also published some really good documentation on electrification of airports. So if anybody's interested in looking at electrification, I would point them that direction.
Okay, great. Yeah, because you never want to dig a hole and then find out, oh, there's where the power lines came through.
There you go. And then putting power lines in an airport are not as easy or nearly as cheap as one might think. It's a challenge.
I can easily imagine, okay, that's where the substation is, and it's on the other side, and we're bringing the power from that direction.
You can't dig there.
Okay, great. Well, thank you very much for spending some time with us.
Thank you for the opportunity.
And we're enjoying the time here at Verticon 2026. And once again, this is Brian Purdy with Florida Aviation Network, live and in the clear. Have a great day. Thank you. Okay.